Assalamualaikum and a very good day to everybody. So today we are going to present our product entitled WOIPS, the Wireless Positioning Framework Utilizing Organic Fingerprinting Method. So this is a work from our research group, the Intelligence Computing and System Informatics Research Group from Faculty of Electrical Engineering Technology, UniMAP. So the main researcher will be myself, Abdul Halim Ismail, Muhammad Karul Bakri, and as well as Ahmad Hakimi, Ahmad Sairi. So this is our research group. So what is indoor positioning system? As you can see here, this is the conceptual application of the indoor positioning system on a mobile robot, where in this scenario we have three mobile robots. Put here, mobile robot 1, mobile robot 2, and mobile robot 3, for which they are navigating and positioning themselves inside the room while doing the routine job. Right? In this case, the uh, medical services. For example, this robot is helping the medical staff to treat the patient, and this robot is following the medical staff into somewhere else, whereas this robot is currently charging himself in the server room. So as you can see here, we depict the positioning system whereby robots are connecting to the wireless infrastructure here. This is Wi-Fi access point 1, 2, 3, and 4. And by using the data from the Wi-Fi, they will try to position and will later on will navigate themselves in the indoor environment. In the next slide, we are showing the advantages by using the proposed WPS system over the normal onboard sensing elements. In the normal application where all the researchers are using is they use a lot of sensors inside the robot. It can be the infrared, ultrasonic, or sonar sensors, and often people are using IMU, initial measurement unit, and compasses, and more expensive laser rangefinder and encoder to determine the robot position and localization system. The merit of this sensing element is its high accuracy, where it obtains a result of centimeters, sometimes decimeters level of accuracy. However, it is very expensive. Furthermore, the laser rangefinder, which is very costly, and of course, it's very complex in term of the algorithm. For the proposed work in the WPS, we only need the wireless receiver adapter for receiving the signal data, and of course the Wi-Fi AP here, or rather the Wi-Fi data, Wi-Fi transmitter, is the one that is currently deployed in all the buildings. In such cases, we doesn't need to employ, or rather we doesn't need to use any other new sensing element. However, because of the signal fluctuative problem, we have a very low accuracies of the system, and it is our task to improve the accuracy. And this system is very cheap and extendable to multiple robots, as you have seen before. The problem with WPS is that if we want to use it indoor, we cannot use GPS because GPS cannot penetrate the inside building. And the system that we propose here is by using, we call it fingerprinting technique, and it works by match with the database obtained beforehand. However, those Wi-Fi signals are very fluctuative due to the local behavior of wireless signals. This is because the fluctuative problem is caused by the signal propagation properties such as diffraction, scattering, so on and so forth. Wi-Fi signal is also changed with environment change, and therefore making the accuracy lower compared to the use of onboard sensing element. And normally in the indoor environment, it is very uncontrolled and very structured environments. This slide will explain how fingerprint works. Imagine we have a room here, or we have a building here consists of three rooms, room 1, room 2, and hall, and we have access point of per each room. Okay, so what we can do is we can measure the Wi-Fi signal data over the rooms. Normally we use an expert surveyor to measure the signal inside the room. As you can see in this example, room 1 detecting minus 45 dB from AP1, minus 82 dB from AP2, and minus 39 dB from AP3. Right? So by using those kind of informations, then when came a new user, a robot for example, or a user, and the user may have this data of measurement. So by compare this value with the table here, normally we use a shortest distance of Euclidean matrix, and we can found that the robot is actually, or the user is actually on room 1 because it have the least minimal distance. So for our experiments, we conducted a preliminary experiment by setting up this kind of area, and we are collecting 9 wireless data, for which one data have about 700 data. That being said, for this particular location, I have 700 data, for which the data are obtained from 4AP. Then you can see here how bad the signal fluctuates over time, and the signal distribution, which is very Gaussian-like. In order to position the user in this preliminary experiment, we use deep neural network, and this structure shows our neural network architecture, which consists of 4 input layers corresponding to each APs, each Wi-Fi transmitter in this example, 2 hidden layers with 0.5 dropout layer, 6 output layers corresponding to the location. Alright, so we are training the data by using the sigma activation function and optimize it using the Adam optimizer. To validate the experiment, we use the hollout method, for which 80% of the data are used for training and 20% are used for testing. So for about 200 epoch, we found that the error is only 62 centimeter in the y-axis and 18 centimeter in y-axis. So the average error is about 20 centimeter. Bear in mind that this is very small scale experiment, and the result is quite good because the environment are controlled. So what is the proposed WOIPS? WOIPS stands for Wi-Fi based organic indoor processing system. This system, the WOIPS, we employ multiple devices which device diversities. In this example, the data or the signal data will be surveyed by an expert, and also we introduce multiple device data collection in the same room, for example. Okay, this is the data from our lab. You see, we have 4 different devices. First one is home there, which is our benchmark. Next, we are using non-MCU, similar to the experiment 1. Number 3 is we're using a small scale robot. And number 4, we are using mobile phone to obtain the data. And for this purpose, we have created an apps which can scan the data, and then the data can be sent into the cloud. Okay, so the difference between the conventional IPS and WOIPS is that in the normal IPS, when the survey is done, it is submitted into positioning system, and then the end user will try to position himself by match with the positioning system. It's only one-way communication. But for the proposed work WOIPS, we employ multi-devices survey, including the 4 things that you have seen before: the robots, the user by using mobile phone, so on and so forth. And then we send it to the positioning system, and the end user will try to position himself, and on the same time we send the data again for the survey. So it's a closed loop system, and we believe that it will be much better compared to the conventional IPS. So that's all for the introduction to our works. Thank you very much.